Alright, so today we have 5 multimeters connected to a power supply. And I'm just curious to see how these things all compare to each other. And the reason why, or where this came from, was a while back I did a video kind of trying to see what the accuracy of these like cheap $10 to $20 watt meters was. And in order to do that, I compared this watt meter versus, I think it was these two multimeters, just to see what kind of the discrepancy between this thing and these two meters were. And of course, that required these two meters to be accurate in order to compare this meter. And I've gotten comments about that. One seemed for sure serious, and one of them I kind of took as a joke when I first saw it. But anyway, kind of my justification on whether or not these meters were accurate is they all read about the same relative to each other, and I don't think that they're all out of spec by the exact same amount. Also, my argument to that video was, well, this meter's like 10 bucks. If you're buying this, it probably doesn't need to be any more accurate than the factory calibration on a meter like this. Now I'm going to start with just DC voltage, and I'm going to try to do DC current as well. That might not be quite as easy, but these are all just kind of hooked into this one power supply. Pretty janky wiring setup, but it just consists of a bunch of banana jacks and some banana plugs like these that I just kind of screwed the meter leads into on some of them because I don't have the adapters like this meter has to just shove it straight into a banana connector. But anyway, these are kind of in order of price, more or less. So this is like I don't even know if you can buy these anymore, this specific meter, but this is like, you know, the $10 really cheap low-end meter. This is a uni-t UT210E, and that, let's see if I can prop that up because the display is going to have a bit of a glare on it. But these run for about $40 now. I think I caught mine on sale for like 30-ish. This meter is about $60, I think. I wouldn't recommend buying one of these anymore. These two, out of the meters that I have here, these two are the ones that I wouldn't buy. This is a Mushi meter, which is kind of this is a weird one. Not a whole lot of people have these, but it's a Bluetooth multimeter essentially. And it works, it's more along the lines of a high precision, high voltage rated data logger. So that's what I more or less use this as. And then this is the Bryman BM235, which is the EEV blog rebranded one. And also, interesting fact, these two are both $125 on Amazon, I believe. I'm putting this one as a higher price meter because I have some accessories and things that actually bump this up to about $150, like the case and things. So that makes this a little bit more expensive. And also, I trust this meter more than any of the rest of these. And honestly, I actually trust the uni-t meter more than this one. But I have not tried this yet, actually. So let's go ahead and kick the power onto the power supply. Put all these into DC volts. The Mushi meter is already set up in that. So DC volts on this meter is this one. DC volts. I never use this little meter anymore either, which might explain why the batteries are apparently dead. You have to fix that apparently. No, wait. Nope, it's not dead. That's weird. Apparently the range switch is going bad on it or something, but anyway, also hopefully the phone screen doesn't have a glare on it for you guys. Maybe that'll help a little bit. So let's see, we're gonna set this first. We'll set it at 1 volt, or we'll see, how low can I set this power supply? I don't even know. I can apparently set it at 0, so let's send 100 millivolts out. I don't think this is gonna be accurate whatsoever. Maybe it will be. Only have a reading here for some reason. Unfortunately, this is an untested wiring setup, so now I have it. There we go. Something about having these plugged in that it doesn't like. Alright, so that was kind of weird. For some reason I wasn't getting any power past these 2 points. Bad connection in there or something, which is not something that I was kind of worried about with this. But according to this power supply, we have 100 millivolts coming out of it, which I think is as low as I can set it. Maybe I can set it lower. Let's try it. I can set it lower. That's really surprising, actually. So right now our power supply, this is not going to be an accurate voltage reference or anything like that, but we're set at 10 millivolts output. So Bryman's reading 0.011, so that sounds about right. This one 0.012, 12.1 millivolts, 12.1 millivolts, and 12.1 millivolts. So these four are actually agreeing with each other quite nicely, and then this one is just a little bit low. Also, I can switch this into millivolt range. There we go, 12.03. So if you put this one on the millivolt range, it does actually seem to agree with these a little bit better. So if I go back to DC volts, there we go. Anyhow, let's go ahead, we'll take it up to 100 millivolts and see what we get. 100 millivolts, we're at 101 over here, 102, 102, 102, 102. So again, this one's just a little bit low, and I should be able to do millivolts here. So it's 102 on the millivolt range, but in the volt range, it's 101, which is kind of interesting, but it just makes it a little bit lower. We'll go up to 1 volt and see what we get. So 1 volt, we got 0.998 over here. We've got 0.9997, so that's basically 1. 1.002, 1.003, and 1.002. So again, this one's reading a little bit lower than these three, but it makes sense with this one, but still really quite close. So we'll take it up to, actually let's go 3.3 volts because that would be another kind of common voltage. So power supply is set 3.3. 3.297, 3.297, 3.305, 3.30, and 3.30. So now these two are almost, well actually these two are the same, and then these are almost exactly the same as well. Continue to bump this up, we'll go up to 5. 5, there we go, 4.98, actually 4.99 is kind of drifting up. I don't know if that's the power supply or the meter. 4.996, so these two are pretty close again, 5.00, 5.00, 5.00. And at this point, if we think about it, if we rounded this to the next decimal place, this would round up to 5.00. So right now these are all measuring essentially the exact same voltage. 10 volts, we got 9.99 here, 9.98 there, which would be 9.99 if you rounded it. 10.01, 10.01, and 10.00. 15 volts, we've got, let it settle in, 14.99, this is saying 14.97, so that one's a little bit lower than 15.01, 15.01, and 15.00. For 20 volts, 1996, 1996, 20.01, 19.9, and 20.00. 30 volts gives me 29.99, 29.95, so this one's actually reading a decent bit lower than this one now, and 30.03, 29.9, 30.0. So this one on the higher voltage seems to be reading about 1/10 of a volt low compared to the rest of these. Of course, this is going to be probably within spec for this little meter. Alright, so the highest voltage I can go with this is 32, and it's actually showing that it's outputting 31.95, but this is reading 31.99, this is reading 31.95, this is reading 32.04, 31.9, and 32.0. Alright, so as predicted, these things don't seem to have any trouble measuring very, very close to each other. Tempted to shove these into an electrical outlet and see what the 120 volt looks like. Of course, that's not going to be very safe the way that this is set up right now, but might as well try it. And actually, just as a test, let's just turn this on at 32 volts and see how quickly each one of these auto ranges. You should be able to see them, hopefully. This looked like a slow one. These two came up pretty quick. This doesn't have to change ranges because it's got this, I guess part of the sales pitch with this meter is that it has a really, really high precision ADC in it, and that you can get these ridiculously accurate voltages like this. But it's kind of weird because the way that they do that is they only have 2 voltage ranges anyway, so it's got a 600 or 60 volt and a 600 volt. Usually what you do with a normal meter is you just have a bunch of different ranges and you switch through the ranges in order to get more accuracy. As you can see, we do have a lot of decimal places on this, so it's pretty precise. I don't know how accurate this actually is. It might be a false sense of precision. As you can see, it is kind of floating around, so really past that third decimal place here, it's kind of useless measurement. Anyway, these all read fairly close to each other. It looks like if I was going to pick one that was off by more than the other ones, it's probably this guy, just because it's reading a 1/10 of a volt low. That's not too bad. And then this, the EV log meter here is actually a little bit low if you're trying to measure voltage on the low side, like 100 millivolts or less. Unless you use the actual millivolt range, in which case it works just fine. All right, let's see if we can't do something dumb with these without blowing everything up. I'm just going to kind of touch the leads across the prongs on our wonderful 120 volt electrical system here in America. There we go. We have 119.5 on the Bryman, 119.2 on the Multimeter, 119.4 on the L&Co, 118.9 on the cheap meter there. Try not to short these out. And 119.5 on the uni-t. So this guy is reading a good 0.6 volts low or so, 0.5, 0.6 volts low. So that's kind of interesting. It's not that concerning. So this one's a little bit out compared to the rest of these. By the way, this is true RMS, this is true RMS. I think that this is true RMS, I'm pretty sure that it is, but these two are for sure not true RMS. Which brings up the next experiment that I'm going to try, and that is, instead of doing that with 120 volts out of the wall, we're going to do it with 120 volts out of a power inverter, and we'll see if they measure any differently. And this is kind of where they're going to start to get separated probably. So I'm just going to take something I can kind of lightly put in here and touch across the wiring. So if we do this, 116.6 on the Bryman, 116.5 or so on the Multimeter. For some reason not measuring anything on the L&Co. Is this in DC still? Was in DC. Now I've got 126 on the L. Oh, that's interesting. This one is not staying in AC volts. It's resetting or something when I do it across an inverter like that. 126 volts it's reading though. 125.5 on the cheap meter and 117.9 on the uni-t. Now, if I was probably going to pick one of these to trust, it would probably be the EV blog one, because I know in the manual it says that you can measure true RMS voltage up to like 440 hertz or something like that, which isn't incredibly fast, but it should be fast enough for this. I'm not sure about the Multimeter. I would probably trust that measurement too. Interestingly enough, this is quoted to be a true RMS meter, and it is measuring a slightly different voltage than these other two that are also supposed to be true RMS. So that's measuring what, like 1.2 volts high or something compared to the other ones. So that's interesting. And then of course the non-true RMS meters seem to be measuring like 7 volts high. When they measure this one, I would not want to use this for any kind of, and this is part of the reason why I don't like this meter. I wouldn't want to be using this for this kind of application, because you notice as soon as I touch this across the pins, you get a reading there, 125.7, and then a few seconds later, for some reason, it just randomly switches into DC voltage mode, and you quit getting a reading. So that would actually be kind of dangerous if you're trying to determine whether something was live or not. But anyway, that was probably the most interesting experiment out of all these, because I was expecting this one, just because it says true RMS, and I was expecting this to line up with these two a little bit more. And of course, I'm mostly trusting this because of the price tag. Same thing with this one. But of course, $40 versus $125. I'm going to probably choose the $125 meter. Unfortunately, I don't have a Fluke multimeter here. If I did, that would probably be the right thing to be trying to judge the accuracy of these things off of, or of course have a proper voltage reference that can put out different waveforms and things like that. So anyway, the next thing I'm going to do is reconfigure all of these things so I can measure DC current. Alright, so right now I have these guys set up to do current, so every one of these meters is wired in series with each other, and then these two will do DC current through the clamp here, and I'm just going to go ahead and zero them both out here. And then on the multimeter, just so you know, this top one is the current measurement. And right now our power supply is set to output 1 milliamp. Also, before I start this, I want to note this meter will for sure be wrong in these modes. And the reason why is when I was using this meter, I blew the fuse out of it a couple times, and I eventually got tired of replacing it because it was a soldered in fuse, and my soldering iron just couldn't get enough power to really solder the end caps on the fuse. So I eventually just put a piece of wire in it, and then I blew the current shunt resistor out of it eventually, and I just replaced it with like a 1 ohm 5% resistor. I'm kind of curious to see what it does anyway. Of course, I don't use the current range on this anymore, but we're set at 1 milliamp. I don't know, let's see, I got a broken wire somewhere apparently. Maybe it's these that aren't making a connection again. There we go. So I got it set at 1 milliamp, and even the power supply knows that's not outputting 1 milliamp. I've got about 4 milliamps running through it, well, according to the power supply. According to this, I've got 6.08 milliamps. This is showing, 6.07. Apparently I have the, I do have these backwards. I can flip this, no problem. Just so it's not showing a negative number. So there we go, 6.01, this is reading 6.05. Now this is actually kind of impressive. The nice thing about the multimeter is the only thing that it has is that 10 amp range, and it seems to actually be able to measure low currents just fine. And that's a good thing because it has a much lower burden voltage, because you're only going through like a 10 milliohm resistor instead of a 100 ohm, or it'd be probably a 1 ohm resistor for milliamp range. So this is reading pretty reasonably okay actually. It's bouncing around a lot for some reason, I don't know why. But it's getting 6.03 just like this meter over here and this meter, so apparently it's pretty close. This is just wrong. That's showing 400 milliamps, and this one's showing, that's showing 4 milliamps, 0.003 amps. This is 0.4 amps, so that's 400 milliamps. I'll go ahead and turn the power supply off again, and I'll just re-zero these two out here. Of course, clamp meters are not meant to measure such low currents. Oddly enough, with it zeroed out properly, 0.005, so that's actually pretty good. And this is measuring 200 milliamps again, so completely useless. And of course, you wouldn't really expect that with the clamp meter. Now, one thing that I really hated about this meter is that it just drifts around all over the place. Even, you expect it to do that when it's moving around because the Earth's magnetic field will mess with it. But the thing just drifts all over the place even if you're not moving it. So I just don't trust the current clamp on this unless I'm doing really high current stuff where it's really not going to make a difference if it's off by a couple amps. And this is kind of the meter that you would use if you wanted that, because it's good for 1,000 amps on the clamp, which is kind of nice. But anyway, I'm going to zero this one out again too, because it's drifting a little bit. It doesn't drift nearly as bad as this one does. Also, I don't know, I've got 0.66 milliamps still flowing through it for some reason. I don't know if that's like a capacitor that's still not discharged, or if it's just leakage out of this power supply or what, but we'll go ahead and bump this up from 1 milliamp to 10 milliamps. So with the power supply set at 10 milliamps, this says it's outputting 13, and we got 14.2 there. This would be 14.74-ish, 0, 100 milliamps, 15.02, about 11 milliamps. Turn this off, and I mean, it could be zeroed better, but it wouldn't make too much of a difference, doesn't look like. So yeah, that's getting up to 13 with it zeroed out perfectly. Go ahead and bump this up again. I say we just go ahead and take it up to about 100 milliamps. So there we go. This shows that we're outputting 101. This is showing 103.5, 103.2, 0.1, which would actually be 100 milliamps. 0.96, so that's pretty close to what these guys are reading. 104. This one's actually surprisingly good for, or surprisingly close to these other ones, even with that horribly out of spec resistor stuck in it. And we'll take it up to 200 milliamps because that's going to be the highest that some of these meters can read. And I'll zero these guys out again. That one already looks like it's zeroed. Turn this on. Meter's unhappy because it's over 200 milliamps. So this is reading 202.7. That's reading 100. That's reading 189. 202. So not bad. Let's see if I just back the current down a little bit and make this one happy. $198 point something, 197. So this one, I'm surprised as to how close that one is. Of course, this is going to be a little bit out. You expect that. But the next thing that we're going to go ahead and do is short this one out because this is the weakest link in the chain. So I can go up to about 600 milliamps with this guy. And we'll shut the power off and re-zero everything. That's the annoying thing with clamp meters. You have to re-zero them every, well, once in a while. We're trying to get really accurate measurements here, which is part of the reason why that's not working too well. Also, this still has about a milliamp of current going through it, which might be another problem when it comes to zeroing these. But they should be reasonably close. So we'll set the current back up a ways. So we'll go ahead, we're going to try 500 milliamps and see what that gets us. So we'll set her at 500, 503, 502. That's actually measuring somewhat close, 3 to 400, and that's 476. All right, and then the next thing, these two should be fine, but I'm going to go ahead and take this out and I'm going to move it into the amps jack. Turn that on again. 506, 503, 300, 476. So this still seems to be pretty accurate in the amps jack with that half an amp going through it. We'll bump her all the way up to 1 amp and see where we're at there. 1.005 or so. 1.001, 0.8, 0.95, about 0.96 there. I'll shut this off and make sure we're somewhat well zeroed. Yeah, it looks good actually. We'll bump it up here. We'll start bumping it up just until we hit the limit of the power supply. So now we got 2 amps. This one's going to shut off because of auto power off. We're close on that one, and then this one, unfortunately, this is manual ranging, so in order to change the current range, I've got to go up and re-zero everything, so we'll do that. Turn that back on. We're still at 1.89, so this one, it's reading a little bit low compared to these other meters. And this guy, let's see, let's make sure it's still zeroed. Close enough to zero there. 2 amps, 1.9, actually that's reading 2.0 right now. So this one is reading fairly accurately, it's not bad. 1.9, 1.998, 2.003, so these two are pretty darn close to each other. This one's reading about 1/10 of an amp low, the uni-t, so that's kind of interesting, but we'll bump that up again. 3 amps, 2.9, 2.86, so this one again is a little bit low. These two are really close to each other. I'm not sure how high this power supply would go. I think it's 5.1 or something like that. That gives it 4 amps, 3.99, 3.9, 3.84, 5 amps, 5.005, 4.99, 4.9, and 4.82. I think that's going to be about as high as I can go, 5.1. So that's all, reasonably close. So interestingly, this one is a decent bit lower than the rest of these, which is kind of interesting. Even this one seemed to be reading more accurately than this one was. Of course, doing current measurements of any kind, it tends to be better to use an actual inline meter, unless of course you can't use an inline meter, in which case you would use something like this. But accuracy wise, that meter's not necessarily bad. I'm sure it's within its spec. Alright, so that's pretty much as far as I'm going to go with this video. I'm not going to go and check the resistance ranges and the diode ranges and the capacitance and all that stuff, because that gets a little bit harder to do than just wiring all the meters in series or in parallel. Alright, so what have we learned here? First off, for DC voltage, all of these meters seem to be very, very close to each other, which I would assume means that they are accurate, because I can't imagine having one or all 5 of these meters being out of calibration by the exact same amount. For another thing, on DC current, all of these meters are relatively accurate. This one seems to read a little bit low with the current clamp. This one was actually a lot better than I expected it to be, just given that it had a really cheap resistor thrown in it as a current shunt resistor, but I'm not going to complain about that. This meter also did better than I expected it to on the lower current ranges. I was kind of expecting it to not be able to measure that too well. And even you can see right now this power supply is leaking about 5 milliamps, and it's still showing that. Also, another thing that I learned here is that this power supply leaks current when it's turned off. So I guess that's something that I probably need to keep in mind. 5 milliamps might still be enough to power something up. Now for AC voltage, with a sine wave, going across the wall, they all seem to be reasonably in line with each other. They didn't seem to be completely out of whack, and of course the AC voltage is always less accurate on these meters than the DC voltage anyway. But once you started messing with the modified sine waves, these start doing weird things. This starts to do weird things where you can't even trust the measurement. Like when it was starting to switch itself into DC voltage mode instead of staying in AC. That's kind of annoying, and it's actually kind of dangerous, because you look at it and you see 0 volts and it's 0 volts DC, and it actually still has an AC voltage to it. So this is part of the reason why I don't really trust this meter too much. Also, another part of the reason why I don't trust this, as you can see, we're still in current mode and it's starting to drift again, so you have to zero this thing out like every 2 or 3 minutes. Whereas this one's still sitting 0.1, no worries there. This meter, of course, these two meters are non-true RMS, so when you hook that modified sine wave up to them, these read differently than the rest of them, so these are reading quite a bit higher than what I think that they should have been. And then this meter was actually, even though it says it's true RMS, it was a little bit off as well, at least compared to these two. It wasn't nearly as far off as these were. Still, actually probably still within specifications for this meter. So I'm not real concerned about the AC voltage accuracy of this guy, though if I want to measure a modified sine wave inverter or anything where it's not going to be a really clean AC signal, I might want to use one of these two meters to do it instead of this one. And of course we're basing this off of the fact that these two meters read very close to each other compared to the rest of these meters. And we know that these guys were wrong for the modified sine wave, because they're not true RMS, and the averaging meters just don't do good with that. Now, one thing that I kind of wish that I had right now would be a nicer fluke multimeter that I could compare these with, because that seems to be, the gold standard in multimeters, and that would probably be a better thing to compare like the true RMS voltages and whatnot with. Now, at least to me, this is a pretty interesting experiment just to see what these multimeters would do. I wasn't entirely sure what would happen. I wasn't entirely sure how close these would be. I've never hooked them all together like this to see what they would do. Like I've said, I've kind of compared one meter to another, like I've compared this meter to this meter and things like that. But I've never done all of them at once. So this is kind of an interesting experiment, at least I thought so. So basically what I've learned at the end of all of this is that I can trust these meters for basic DC voltage and current, though this one might not be the go-to if I want a really accurate measurement. Neither is this one really, just because it floats around so much with the 0 point, which was just kind of an annoying thing, and you have to zero it out every 2 minutes or something like that if you want to have an accurate measurement. And really in that case, this probably ends up being the best current clamp meter, because you can see the 0 is actually holding there quite nicely. It's still showing that we're passing like 10 milliamps or something like that, and it's been like that for quite a while as this one continues to drift further and further. So if I need a current clamp, I'm going to use this meter. I already really haven't been using these two meters too much lately, and this has been my go-to for most things, honestly, because I've just left it on the bench, and then if I need the quick current measurement, I can put the clamp on it. I have the leads as well, and it does pretty much everything I need it to. And if I want something to be more accurate or more precise, I can use these 2 meters. Now, of course, I wouldn't normally use this as my main multimeter because of the fact that it has to have a smartphone, or usually I use my tablet with it. But if I need something that's wireless like this, I would use this, or if I needed a data logger, I would use this thing, because that's about all I have for a data logging multimeter like that. So anyway, hopefully you guys enjoyed that video, found it interesting. If you did, hit that like button, consider subscribing. You can also follow me on Twitter. The link is in the description. And that's about it for this video, guys. Bye.